My name is Ovais. I work at Uber as a story SRE. Prior to that, I was working at Lithium as a SRE, and before that, I was working at Percona. Um,
I'm Ilan Rabinovitch. I work on the technical community team at Datadog. We're a monitoring as a service company. I'd love to chat with you at some point later about what we do, but we'll keep the commercial here short. Before Datadog, I ran automation and tooling teams for companies like Uyala and Edmunds, where I got to try to build my own monitoring systems and sometimes succeed, sometimes fail spectacularly, and we'll talk a little about that today.
so before I proceed, I just want to say that while we prepared for this talk, I was still working at Lithium, so all the examples and data we talk about is really Lithium's data and not specifically Uber. But the examples or the description or the theory that we'll talk about would be in general and would apply to anyone running MySQL at scale. Cool. About Lithium. Lithium is a social analytics company. They have about a dozen different applications which deal with helping brands monitor their customers and see their social interactions. So there's a lot of data, social data that comes in and that needs to be monitored. It's a typical SaaS application with one customer per schema. So that's how the data is sharded. As I mentioned, there are dozens of applications. Every application has its own MySQL infrastructure, has its own set of MySQL machines. And it's a typical replication setup, master-slave setup using asynchronous replication. The cool thing about running MySQL there is that we have different types of infrastructure. For example, we have legacy infrastructure where we were running MySQL on bare metal. With respect to that, we were running MySQL as a single instance on a bare metal machine. Some instance, we were moving towards running multiple MySQL instances on a single machine. We were also using AWS public cloud for regions where we did not have a presence in a physical data center. And we were slowly transitioning to OpenStack. So some of the development and staging environments were using OpenStack to host MySQL databases. So it was a really unique challenge. We had to come up with a monitoring solution which could work across the board with different types of use cases. And this is an example related to one of the applications. The MySQL machines related to one of the applications. And this is the thing that I wanted to share here first. When we started overhauling the monitoring solution that we were using, this is what we did first. So the first thing we did was look at a summarized view of our MySQL infrastructure and see what's happening at a bigger level and not just look at individual machines. And as soon as we came up with this particular dashboard, immediately we realized that we were not really utilizing the hardware in a way that we should utilize. The workload was not consistent, and that's why it was lacking stability. Some of the masters had much more workload, were doing a lot more QPS as compared to some of the other masters, while some of the masters had high latency. So the real purpose of showing this dashboard initially during the presentation is to understand that what we would be talking about is really looking at MySQL not at the host level but at a service level and looking at stabilizing and providing consistent performance for MySQL.
Do a little. So we're here at a conference mostly focused on data, but I think data and databases and data stores. But as we talk about monitoring and DevOps and all of the things in this space, I think it's important to kind of quickly define what we mean by all of that, and to be clear that the data teams are not in any way excluded from this DevOps worldview. So John Willis and Damon Edwards, who were sort of some of the thought leaders in this DevOps space a couple years back at DevOps Day LA, defined this acronym CAMS, where they talked about culture, automation, metrics, and sharing as sort of being the way they define DevOps. And when I say culture, what we're talking about is things is the idea of people over process, right? Your teams need to be working together collaboratively in order to, otherwise, regardless of what tooling we give you, what metrics you have, you're not going to succeed, right? And that means, I think, when we say DevOps, really what we mean is, star ops or so, you could put, asterisk, splat, what have you. You can put DBA in there somewhere. But the idea is that all of our teams need to be working together and on the same page. On the automation side, this is, Ovais will talk a little about some of the things that they've done around databases at Lithium and some of the other tools they've built. But the idea is to scale with code rather than people, right? A lot of us here, I guess, get a sense how many folks are working in some sort of environment where you're using some amount of cloud or some sort of APIs to drive your infrastructure. One or two? Cool. More. Folks are a little shy today. So you can imagine we're looking to do things. As we're scaling up and down, we're looking to do things as fast as we can. Again, using that code rather than driving people to work, many hours manually configuring things. And then finally, metrics. We want to be measuring where we're going, making sure that we're successful, understanding how our customers are experiencing our services, whether those are internal customers or external customers, and then sharing. The idea that we should all be looking at the same data, working together across teams with that data. Again, none of these things, if you're not sharing those metrics, what's the point in having them? You end up in a situation where like that, the mission to Mars, where one team was working in pounds, one team was working with customary measurements or English measurements, and other ones were working metrics. Next thing you know, we're looking at different data. Things crash into planets, or likely less so. You're likely returning 500s rather than 200 somewhere. So yeah, we're all in this cloud world, and everything we think it's awesome. We've got things. It's made our lives easier in a lot of ways. We've got things like managed databases that maybe we don't have to tune as much ourselves. We let our providers do it for us. We've got things like auto scaling. Whether we're in Amazon or what have you, so the systems are coming and going as we need them to. We have things like container orchestration. This is the Kubernetes logo. Lithium's been doing quite a bit with Kubernetes lately. We've got infinite storage, and all of this even exists in our private clouds. Right? We're no longer in a situation where scaling is how quickly can you get somebody to the data center to shove more systems in a rack, but rather, what's the limit on that credit card, or or at least how large of an invoice will your provider let you have? So a lot of the things that we sort of dreaded dealing with back, maybe 10 years ago in terms of, how quickly can I get these servers in from Dell or HP or whomever, sort of, I don't want to say they're relic of the past, but at least we've got a lot of solutions to make that happen faster. But that doesn't mean we can sort of take our eyes off the road. Bad things happen. It's going to rain. We're going to have storms, whether those be incidents or bugs in our code or what have you. We need to have visibility into what that looks like. So just like we wouldn't drive down the street without our wipers on in the rain or have our headlights off, we're going to want to have monitoring. The idea is to sort of have a monitoring first strategy, collect all those metrics long before you get into production, start in somewhere like staging or development environments, and even in your local environments. Make sure that you're measuring how things are going, the same way you would have a test-driven development process for your applications. Have a monitoring-driven development process as well. Because the reality is that collecting all of this data is quite cheap when you have it, but it starts to get but trying to explain to somebody why you don't have it later, that's the expensive part. Trying to invent later on some data as to why an incident occurred. How many folks have had an incident or an outage occur where the action item was, we'll add more monitoring because I'm sorry, I don't know what happened. Yeah, right. It's not a good situation when you send that postmortem out to your customers or to your boss. They start to wonder whether or not, we actually have our eye on the ball. So when things happen, we really want to have that data available to us, and we want to know how we ended up in those situations and be able to go back and make some decisions on how to prevent these things from happening again, or hopefully prevent them from happening at all. So yeah, instrument all the things. What does that mean, and how do we go about doing that? This of course means quite a bit of data. We're in the data world, but this adds a bit of complexity. How do we define operational complexity? We talk about it in the sense of the combination of things to measure and the velocity of a lot of that of the changes that we're seeing, right? So to give you a sense, this is just kind of looking at sort of our average Datadog customer, the type of data that they're collecting. We find if they're in Amazon, they're collecting on a given instance, they've got somewhere around 10 metrics from CloudWatch that they really care about. The operating system itself, they probably have another 100 metrics or so. From MySQL out of the box, we're finding you get about 350 metrics. Ovais did quite a bit of development for us to help collect a lot of those in our open source agent.
So when you're talking about 350 metrics, it's not just status variables. You're talking about some of the metrics are exposed by performance schema. For example, some of the metrics you can fetch by parsing InnoDB status. And a lot of that is how Datadog is collecting metrics. So with respect to Datadog, the metrics are being collected both from status variables. In some cases, global variables or actual variables are also being used. For example, when you're collecting metrics, it's about how table cache is being used. You also want to see what the size of the table cache is. When you want to see how buffer pool is being used, you also want to see what the size of the buffer pool is. And then performance schema also exposes metrics. For example, you can use event summary, statement digest, table and performance schema to look at what the latency looks like. So there are different sources that MySQL provides, and especially with 5.6 and 5.7 coming in, performance schema is really an eye-opener, and this number is just going to increase.
Cool. So if we start to do some of that math, assuming you have somewhere around 100, in a large-scale environment, you have somewhere maybe like 100 slaves that you're MySQL slaves of some sort that you're monitoring in one way or another. At 460 metrics per host, that quickly adds up fast. And when you're talking about keeping these at second-level granularity or possibly sub-second, this clearly adds up fast across your infrastructure, and you have to have somewhere to keep it as well as a way to think about it. So that's that when we're here, we're talking about the number of things that we want to monitor. Sort of moving on, we're talking about this velocity. So we're in a container world or in a dynamic infrastructure world, right? A lot of this is we used to kind of name your systems, maybe name them after the planets or some Greek god or something like that, and you'd love them, you'd tune them for years. I know some folks are rolling their eyes and not as excited about such naming schemes, but the reality is this is something that we were doing in our data centers, even at medium scale, right? Systems would hang around for years. You'd wonder what that thing did before you unplugged it. I'm not saying that all went away, but in the world of the cloud and the world of automated infrastructure, dynamic infrastructure, what we're seeing is hosts going away much more quickly. For example, on containerized workloads, what we found is that average VMs in Amazon these days last about 12 days. Average container is lasting about 3. And so you can just imagine, and that's from data we collected back around October. So the graph's sort of going more down this way than upwards. And so as things are changing, that this adds to the operational complexity we were talking about, right? Things that we used to measure in hours are now in minutes or seconds. Things that we measured in days are now in hours. We're probably doing, hopefully you're doing some amount of continuous deployment, continuous integration, continuous delivery within your organization as well. That just adds on top of this. So we'll start, just kind of shift focus. So as we're starting to do this, what are some of the tools that we need and what are some of the challenges that we've run into with our existing monitoring setups?
Okay, so most of the monitoring setup or majority of the monitoring setups that I've seen, especially that I saw when I was working at Percona and looking at different kind of customer setups, most of the customers are using static monitoring, which hadn't really adapted to the dynamic nature of the cloud. For example, majority of them were Nagios-based, cacti-based, so it was all static. It was very painful to detect when a host goes down or goes up and update, for example, Nagios configuration on the fly. Initially, we were doing the same thing at Lithium. For example, we were using Chef, but the time it would take for Chef to detect a new instance that come up was too long. For example, we were running Chef at 15 minutes intervals, so it would take a lot of time. It would take about 15 minutes for it to detect. And what if some problem happens during those 15 minutes? It's not unheard of that the instance faces some kind of an issue as soon as it comes up. So that was really a challenge. And what we really wanted to do was have some kind of dynamic monitoring. And when we're talking about dynamic monitoring, we also have to see how the landscape is changing. A single host is not only running a single service anymore. A single host may be running multiple services. For example, in case of Lithium, a single host was running multiple MySQL instances. And that also was something that was difficult to manage with Nagios. How are you going to manage that? Maybe set up some kind of virtual host name and do something like that. So once you start thinking about where the infrastructure is going and how we are working towards the cloud, really makes sense that you need something that can spin up, some kind of monitoring that can spin up as soon as the instance starts, some kind of agent-based monitoring that immediately understands that a new service has come up and immediately starts monitoring it.
So I mean, the other thing here is, you likely have your environment as you're running multiple services, sort of, and getting this complexity. Really, what you want to be able to do is take a lot of this data from multiple sources. In addition to your host level or infrastructure level monitoring, how many folks are using some sort of a tool that lets them do query analysis or is specific to a particular part of their tier? Maybe you've got something around for specific to monitoring Hadoop, maybe something specific to monitoring Cassandra, something specific to monitoring MySQL. And you start to get a crink in your neck as you're trying to look at all those different dashboards above your head and the screens, that you're interacting with. So regardless of what tool you end up landing on, the idea is, we want to make sure that all of this data is coming together and that you can collaborate on the data from your different teams, whether it be your profiling tools, your database monitoring tools, your infrastructure monitoring tools, all in one place, so that you can start driving some insight across them rather than, constantly flipping between windows and screens and trying to figure out which line up the timelines between them.
So, could you go back to the previous slide? Okay. So another thing that's important to understand here is that MySQL does not really work individually. There are a number of different services that are running together in MySQL, and especially when you have a distributed application, for example, it might be talking to Redis for caching, it might be talking to Cassandra for some different kind of workload, it might be using MySQL, Apache, HAProxy. There are a lot of different things that are going on. And when you want to look at what you really want to know in terms of application performance is you really want to first take a look at metrics in a holistic way, and then you want to be able to drill down. So a lot of different monitoring solutions that we have, especially for MySQL, do not really work well when you start thinking of that mentality, because you have something that's very specific to MySQL or that's only focused on MySQL, and then you have other metrics that are spread out somewhere else. What if you wanted to correlate how traffic increases is affecting MySQL? What if you wanted to see work on the capacity planning and you wanted to do capacity planning based on application traffic? How would you translate that to MySQL? All of these things, you can only answer these questions when you're measuring all those metrics together. Yeah, next. Next. That didn't change. And so this is also something that you need to look at when you start to monitor MySQL or any other system at scale. You don't really want to look at average performance. What you want is consistent performance throughout. So you want to look at outliers. When you talk about consistent performance, you want to look at outliers. You want to detect systems that are performing, that are not behaving as well as compared to other systems. And that's where outlier detection comes in. For example, in this example, you can see how a particular machine has a higher query response time per schema, a particular machine has a high number of queries per second. Once you start looking at these metrics, once you start looking at these outliers, then you can start working on shifting your workload in a way where you start dividing the workload equally among machines. And that's how you can start doing much better capacity planning. When you know what the limits of the individual machines are, and once you have distributed the workload evenly across all the systems, then you can start doing better capacity planning. This is something that Datadog provides out of the box. Next.
So another thing we need to start doing as we're looking at this is, this is a model of the Ptolemaic solar system, right? What we're looking at here is the crazy machinations that one had to do to try to figure out where things were in our solar system when we said the Earth, when we said the Earth was at the center of the universe and everything sort of revolved around us. And it's a similar thing that you need to start. The similar thing that you find yourself starting to do in the world of monitoring when you've got things changing around you all the time. Historically, we've looked at things. We've said to save services up, we'd say something like, is MySQL listening on port 3306? Great, we're done. The host is up. And the reality is we don't care about individual hosts. I mean, we care about those outliers and how they might impact our customers. But what we actually care about are the services that run them. Our users don't want to know, is an individual server online? They want to know, is the service online? And so as you start to try to figure out if the service is online by looking at it from a host level point of view, there's definitely some challenges and definitely some complex equations they have to do. But if you flip this around and you start looking at it from the other way around, and you say everything revolves around the service, and you start looking from a service-centric model, things become a lot easier. It's much easier to tell if the service is down if you're monitoring it as a service rather than monitoring it as individual hosts. And there's lots of ways to go about doing that, but we need to have that mental shift in our head that the host itself is dead. We don't really care about those anymore. What we actually care about as we have these higher level abstraction layers in our environment and this automation is that service. And that's really what our customers are excited about, what their customers are asking us as providers to do. Yeah. So as as we start to look at our monitoring systems and some of the tooling that we've had in the past around this, it kind of feels like a little bit of a relic of the past. Whether it be scripts, whether it be Nagios, whether it be some sort of other static tooling that we've had in place, they served us really well in the last 20 years. I mean, Nagios and a lot of these tools are actually about to hit 20 years old, believe it or not. And so they're starting to show a bit of their age. And so we have to start looking at it from a different approach and different set of tooling.
This shows our transition from an earlier typical Nagios cacti setup. That's what we had earlier. We had, as you were talking about, we had a very host-centric view of things, which was not scaling, especially once we started using OpenStack and AWS. There was static configuration. One of the biggest things that was missing was lack of context. Lack of context is very important, and the reason it's important is that when you're talking about scale, you're talking about a lot of MySQL failovers, for example, happening at a lot of different times. So for some maintenance reasons, you're upgrading MySQL or machine dies. And if you look at Nagios specifically, there's no context. There's no concept of tagging machines in a way so that even if a host changes, you see the same graph. That's not really possible with Nagios. So what we were looking for was some kind of contextual information so that even if a host changes, because we are looking at the service, if a host changes and it introduced some kind of latency or some kind of an increased I/O latency, we were able to detect that. You had a question? Okay. Again, can you go back? There was no correlation between alerts and graphs. For graphs, for example, we were using something else. For monitoring, we were using something else. So we were not really able to correlate alerts or with different kind of metrics. For example, if we wanted to understand was an app upgraded at the point when we hit alert, what was the impact of that? What was the impact of an app, new version of app on query latency or on the query throughput? Did it cause much more queries to be executed and things like that? And finally, the most important thing was no self-service for developers. Ilan was talking about DevOps. One of the core principles of DevOps is for developers to have a control over a service and to understand how a service behaves and have that operational mentality when they start building an application. And that operational mentality can only come once you start monitoring a service as soon as the service comes into being, right? And for example, with Datadog and all the integrations it provided, it was very easy for developers to create their own dashboards to start monitoring a service as soon as it became alive, which wasn't really possible with Nagios. With Nagios, they had to learn how Nagios works, and different people were changing Nagios configuration at the same time, causing conflicts. So self-service was lacking, and self-service is very important, especially at a scale when you're working with hundreds of microservices and you want different teams or different individuals who are developing the service to be responsible for those services. You want to provide them with a tool that would allow the services to be monitored in an efficient way right from the start. Finally, when we started looking at the tooling, we wanted to see how much of an engineering effort would have on us, how much would we have to pay for storage, especially once you're talking about gathering millions of metrics. You start to think about storage, you start to think about operational complexity, you start to think about engineering complexity. And at that point, you have to make this decision whether you want to deal with this complexity on your own or whether you want to use some other service. It really comes down to whether you have that amount of engineering firepower available to focus on what the business needs or to focus on developing something that's already been provided.
So as we're starting to look at this, what you really need to, in addition to the tooling, the other thing is what do we do with all of that data, right? We can't page our engineers on every one of those 46,000 metrics every time they move one way or another. So we need some sort of tooling to think about it. We need some way to pick up that signal, and it's got to be tools and processes from the modern era, not a relic from not a relic from the 1960s. So what we started to do as at Datadog was we captured a lot of the learnings that we've had over the last the last couple of years from our customers. Some of the things some of the writings that Baron from Vivid Cortex has done, some of the writings that folks from Google have done, really captured a lot of that knowledge and tried to summarize it in a set of guides on our website. So there'll be a link to this in the resources, but I'll give you the TLDR edition as we're here in the talk, and we'll start to apply that a little bit later to some of the experiences that Ovais was having at Lithium. So the first thing that you want to do as you're starting to figure out what to do with all of these metrics is to identify which ones are important. Which ones do you want to alert on? Which ones do you want to collect? I know we said all of them, but we need to refine that a little bit. And so what we recommend folks do is to start to break these down into 3 categories: work metrics, resource metrics, and events. So work metrics, if you think about your app or your database or your environment as a bit of a factory, those are the things that you're outputting. So let's say you're a car manufacturer. This is what you're monitoring here is the output of your assembly line. Work metric throughput would be things like how many cars are coming off the end of that line at the end of the week or end of the day. Success versus error rates would be things like how many wheels are missing, how many of those cars showed up without wheels missing or a crack in the windshield or what have you. And performance would be performance is how quickly you can turn those around, for example, things like latency that you might experience in your customers. So as you flip that around, what does that look like in a web environment or in a database environment? Right, on a web environment, maybe throughput is queries per second against your APIs. Successes versus errors might be 200s versus 500s. And then of course, performance, as I was saying, would be things like query latency. How long are folks waiting for those things to return? On the resource side, what we're talking about are things like the rubber that goes into making those wheels, or how many wheels you have sitting around in the warehouse ready to put on the next car, and what does the utilization in your environment look like? Could you spin up and create more of those cars next week if you got more orders in? Things like that. And then events finally being, these are the things that provide the context. A lot of what Ovais was talking about earlier. Did something change in your environment because you changed the formula or the plan for how you're building those cars? Maybe your code changed, and that's why the query performance has changed in one way or another. So these are all things that provide context. They could be business-related events, things like where maybe your CEO just opened up pre-orders for a car you don't have yet, and now you have a huge backlog of things, Teslas and all that. Maybe Amazon's auto-scaled things out from underneath you in your cloud environment, up or down or what have you. So these all provide context as to why an incident occurred or why metrics have gone one way or another. So as we're diving into this, again, we've now categorized all of our metrics. We have a sense of where they all lie, and the question is, when do we page our engineers? When do we wake them up? What are the types of things that we would look at? And so what we recommend is paging on those work metrics. Those work metrics are the symptoms that are impacting your customer. They're going to be the leading indicators that let you know whether your environment is operating operating in the method that they expect. That's not to say that those resource metrics and those events aren't important, but what you're going to do is you're going to use them to diagnose what's going on. So you got paged, maybe query throughput is down. How does that, how was that impact? What was the cause there? Was it maybe a lack of resources? Was it maybe a change in your environment? What have you? Now remember, you can't ignore all resources. I know I'm saying don't page on them most of the time, but if your disk is full and that's your resource and nobody can insert more into your database, you probably want to know about that long before the insert stopped working. So there are some exceptions. You have to sort of apply this to your own environment and figure out what makes sense. But it is but this is generally a good rule of thumb. And so as you start to get, when you do find yourself in an incident, what the workflow that you're going to start to take as you're going through this is to start with that work-related metric that likely paged you or that you're trying to diagnose, and start to work your way down the stack. So whether you're at the front end with an API that you're returning to your customers, or you're all the way at the back end with a data tier service that you're providing, you have a work metric. And the important thing to figure out for yourself is, what is that work metric? As a DBA or as a data engineer, your work metric is likely going to be things like queries per second coming out of your database, and you're going to want to look at that and make sure that you're measuring that. It's the thing you want to measure your success on one way or another. And the teams above you in the stack, or to your sides in the stack, are each going to have their own work metrics that roll up into this. And so if you categorize your metrics in this way, it's going to be fairly straightforward for you to start identifying those incidents when they arise. or the root cause of them, so that is.
So once you start thinking of database, once you start thinking specifically of MySQL, and once you start thinking of work metrics, you need to understand what your end user cares about. The end user in case of MySQL is an app, right? And what the app cares about is how fast a database can return a query. So the most important metric to measure is latency. The other thing that the app cares about is is whether MySQL is available or not. So that's another important work metric. So, for example, here you can see that here you can see some examples of work metrics. For example, query response time, which is latency, queries per second. And once you start drilling down and looking at performance schema and MySQL status variables, you can drill down further and go further into what's the rate of queries per schema. For example, if it's a SaaS application where each customer has a different schema and they're all sharing the same resources, you want to understand how a particular schema is affecting other schemas. Obviously, there's a limit on the number of queries per second that a single MySQL master can do, and you want to understand what the utilization looks like in terms of how a particular schema is using MySQL instance, so that you can start moving things around much more quickly. Next. So once you start drilling down, as I was talking about, once you start drilling down, you start looking at different schemas, and as you can see that once you start looking at different schemas, you can see that some schemas have higher throughput, some schemas have a higher response time as compared to some of the other schemas, and that gives you an extra vision into your system, which you can utilize to start providing that consistent level of performance that I was talking about initially. Then finally, some of the resource metrics. Disk space usage is a very good example. So although we are focusing more on work metrics, but there are some resource metrics that might affect you in a way that you cannot ignore them. Like Ilan gave an example of disk space usage. If you do not have enough space, you cannot insert any new records, which obviously means that there is no availability to the app, write availability to the app. Then the number of threads connected, how many threads are connected, how that's affecting the database, what's the maximum number of threads that can remain connected, what's the maximum number of threads that can be created on a particular machine. Then threads running, which comes down to concurrency, what kind of concurrency MySQL can handle. For example, older versions of MySQL did not handle thread concurrency inside an ODB that well, so that was something that you wanted to measure. Then connection errors like aborted clients, aborted connections, which are also important metrics to look at, and how many times max connections has been hit. So once you start looking at resource metrics, what you really want to do is you want to look at utilization, and you want to stay ahead of the utilization curve, and you want to understand what kind of capacity planning you have to do. Then the next thing you want to do is look at events and how they correspond to different kinds of behaviors or performance impact on MySQL. For example, was there a configuration change in MySQL? Was suddenly the size of the redo log reduced, and that caused a decrease in the amount of write queries that could be executed by MySQL? Was there a recent code deployment that increased the number of queries that were being executed, which shot up the amount of throughput that was going in and reducing capacity for the same amount of requests? Was there a MySQL upgrade? This is especially an important one. MySQL upgrade is very important because obviously there are changes in optimizer that cause different behavior with different queries, with some indexes not being used, which were being used in the past. And then was there a failover performed? Was MySQL failed over to a machine which did not have a hot cache, or you did not have a process which was continuously keeping the candidate master hot and the recent data in cache, which would have an impact on the query latency and things like that. So you want to correlate these events as much as possible to understand where the impact is coming from. So once you're doing diagnosis, you want to go and find out what caused this, and events correlation to these kind of metrics is very important. this is just another example of, this is a real life example of how event correlated to an increase in resource utilization. And as you can see that this is really important data and something that we have used with Datadog. For example, we integrated MHA helper with Datadog so that whenever a failover would happen, an event would get sent to Datadog, and then that event would show up in the dashboard, and we were able to see whether a failover had any impact on how the query response time looked like for the application. So moving forward, I would show some. I would spend some brief minutes on looking at some examples and the kind of dashboards that we used to have that I created and we used to have at Lithium. This again is a summary dashboard that I showed in the start, and like I said, it's really important to look at summary information, and instead of looking at individual hosts, to start looking at what it looks like from the top level, and start looking at how workload is distributed, whether it's distributed evenly or not. And once you start looking at that way, you can start doing better capacity planning. So that was a summary view, and this was a more detailed view. For MySQL, so this slide has some graphs with some metrics, and the next slide has graphs and some metrics. This should give an example of what you should be monitoring. For example, in this case, obviously query response time is an important thing to monitor, which is a work metric. But we are also monitoring things like the server metrics like CPU utilization, disk space utilization, network traffic, network errors. We are monitoring the response time per schema, the amount of QPS per schema, the number of threads. For example, in ODB, checkpoint age is a very important metric to properly size the redo log, row log time, row log weights. So these are metrics that will help you to really understand what's going on inside MySQL. And these are some other metrics. Number of transactions that are happening, the different type of selects, so that you can see how many full table scans are going on, MySQL temporary tables, how many of those temporary tables are on disk, how many of those temporary tables are created inside memory. So these are the set of metrics that I recommend you look at. Some of these graphs include multiple metrics together because it doesn't make sense to have rows inserted or rows deleted, rows read in separate graphs. Because once you want to understand the workload and see how the workload is distributed, you want to look at those metrics together and understand what's going on. Okay. So this short example corresponds to a problem that was diagnosed using these graphs. We saw an increase in load average on a particular machine. And we started drilling down and trying to understand different metrics together to make sense of what's going on. So we saw an increase in CPU utilization, and we saw an increase in load. So once we saw an increase in load, we wanted to understand whether it was CPU bound or IO bound to start with. And so we started looking at metrics related to IO latency and metrics related to CPU utilization. We noticed that there was no increase in IO latency, and there was no increase. There was an increase in CPU utilization. So clearly, the workload had not changed in the sense that it didn't become IO bound. It had remained to be what it was. So there was the change. Whatever the change was causing it to be more CPU intensive as compared to more IO intensive. Once we kept drilling down, because we were also graphing query response time per schema. So we were really able to come down and see who was being impacted, which customer was being impacted. In this case, for example, you can see that Group Casino was being impacted, and you have the replica set name there, and you also know that this is affecting the active master. So once you start drilling down, and once you have the proper graphs, you are immediately able to identify which customer is affected, and then you can correlate that to the application performance side for that customer. Then moving on, we started to look at more metrics to understand what was going on. The other change we saw was an increase in ODB buffer pool utilization. So as you can see, this actually is plotting buffer pool read requests and buffer pool reads. So there is no increase in buffer pool reads, but there are biggest spike in buffer pool read requests, meaning that whatever workload is being is fetched, is cached, is inside the buffer pool, and there are no the data that is being fetched is not being fetched from the disk. Moving on further to identify a problem, we started looking at different type of select types, and we noticed that there was no increase in the number of select types. The workload was evenly distributed between the number of range scans or full table scan. There is no increase if you look at the bottom graph. But the interesting thing is the increase happened in the number of handler read next requests, which means that the number of rows that were being read in case of a range scan. So in this particular example, what it came down to was that there was no change in workload whatsoever. There was no change in the number of queries that were being executed, but MySQL had stopped utilizing an index, and we're using a different index, which was causing it to read a lot more rows as compared to in the past, and we solved it using false index. So once you start looking at once you start drilling down, as you can see that we drilled down, we found that the workload had not become IO bound. There was no change with that spec. We found out which schema was affected, so we found out which customer was affected, and finally we found out what kind of change it was. And then using some other tools like Vivid Cortex to look at actual queries, we were able to drill down to the query and fix it. This really is a summary of what I just talked about.
So anyways, in summary, we're just sort of the key thing as you're looking at monitoring is to kind of figure out what those work metrics are for you and what those resource metrics are for you, and figure out how to apply that in your environment. We think that if you apply this pattern within your environment, you'll find yourself with an opportunity to stay out of the doghouse, keep the folks, keep everybody around you happy. We put together some resources here at the end. They'll be in the slides. No need to start to jot long URLs down. But if you're interested in learning more about how to apply this, our monitoring 101 patterns in your environment, or to dive into the performance schema and some of the other metrics that MySQL has available for you, there's about 5 or 6 resources we put together in the slide deck. And with that, I think we're done. We're happy to answer any questions or do some Q&A.
One more thing, if you want to see how the metrics are being collected, you can look at Datadog agent, which is on GitHub. It has all the it's open source, so you can look at the agent code and see what's being collected, how it's being collected, and you can file pull requests if you need it. That's how I added some 150 plus metrics in the 5.7 release of Datadog agent. Any questions?
Cool. Great. Well, thank you very much, everybody.
Yeah, thank you.